Hi, good morning everyone. Today we are going to learn about how to derive cost function from production function. In economics, it is known as dualism in production. That is, we can maximize a production function subject to a cost constraint. Similarly, we can even minimize a cost equation with respect to a production function. So for its production and cost functions are simultaneously related. Therefore, it is very easy for us to derive the cost function from the production function. We all know the difference between short run and long run cost function. Cost function in general is derived from production function, production expansion function, and also with the help of cost equation. Okay, let us move on to the procedure of deriving a cost function from a production function. Let us take an example for production function. We can take Cope-Douglas production function. We know that the Cope-Douglas production function is in the form that Q is equal to AL raised to alpha K raised to beta, where Q is equal to the total output, A is equal to efficiency of the entrepreneur, and L is equal to labor, K is equal to capital, and alpha and beta are known as the factory intensity. Shows the factory intensity. It is also shows the technology, and it also shows the returns to sale, product elasticity, etc. all represented by alpha and beta. And in Cope-Douglas, one of the assumptions of Cope-Douglas production function, this alpha and beta is equal to 1. Let's say linearly homogeneous production function with the degree of homogeneity is equal to 1, and it also represents the constant returns to scale. That is alpha plus beta is equal to 1. And we can take the cost equation. C is equal to WL plus RK, where cost is the sum total of cost incurred on the labor factor and also the cost incurred on the capital K capital factor, and W and R represent the factor prices. W shows the wage and R shows the rate of interest. Let us move on to the maximization of production subject to the cost equation. And we know it's a constrained optimization because a producer maximizes his output subject to the cost constraint. And finally, a producer reaches the equilibrium condition by maximizing his production subject to the cost condition. Then in equilibrium, a producer is in equilibrium when the slope of the production function is equal to the slope of the cost equation. The slope of the production function is represented by the marginal rate of technical substitution, that is dk by dl. That is the rate at which capital is substituted for labor in order to remain on the same isocon or on the same production level. And the slope of the cost equation is represented by the ratio of factor prices, that is it is equal to W by L. This is the equilibrium condition of the producer. Okay, let us combine in order to reach this equilibrium condition. Let us combine the production function with the cost equation. That is, let us take another variable called Z. Z is the combined function in which we are combining the output or the production function with the given constraint. We are optimizing a constraint optimization procedure by using lambda. That is A L raised to alpha K raised to beta plus lambda into C minus WL minus RK. And the first order condition for the product maximization is we have to maximize this set with respect to K, with respect to L, and with respect to lambda. All these first order derivatives should be equal to 0. First order, so we are going to find out the first order partial derivative of Z with respect to labor. This shows the partial derivative of z with respect to labor, and we have to set it equal to 0. Similarly, we will find the dz by dk is equal to 0 and dz by d lambda is equal to 0. Then here we differentiate the entire function with respect to the labor. Therefore, we are following the differentiation. Here a k raised to beta is constant. We have to differentiate this function with respect to L only. Therefore, it is equal to alpha a L raised to alpha minus 1 k raised to beta. Then here again we have to differentiate with respect to L. The lambda is common for all these factors. Therefore, minus this minus into lambda w is what is remaining here. Similarly, we will find out the differentiation of the function with respect to capital. Therefore, it is equal to beta L raised to alpha k raised to beta minus 1 minus lambda r is equal to 0. Then next we have to find out dz by d lambda, that is equal to, we have to differentiate the lambda part. Then this entire c minus w L minus r k is equal to 0. These are the first set of equation that we derived from the production maximization subject to the cost constraint. Then by rearranging the first two equation, we will get alpha L raised to alpha minus 1 k raised to beta is equal to lambda w, and beta L raised to alpha k raised to beta minus 1 equal to lambda r. The next we will differentiate, so we will divide the equation 1 and 2, and by we strike out all the common factors, and what is remaining here is alpha by beta. The next L raised to alpha minus 1 minus alpha, therefore alpha minus alpha will be cancelled. Then here what is remaining, L raised to minus L, and here k, then it's equal to k by L is equal to, here also lambda and lambda it's vanished. Then what is remaining is w by r, and this is the portion that is remaining. And solve this equation, that is why this is obtained by dividing the both these two equations. Then solve this equation for k, we will get w by r, then this alpha by beta will reach at the other side, it will become reciprocal, that is beta by alpha. Then divide by L will reach to this side by multiplying into L, and this is the equation of capital, and we call it as equation as equal to A. Then the next step to find out the cost equation is to substitute this k into our production function. Our production function Q is equal to a L raised to alpha k raised to beta. Therefore, in the first step we will find substituting this capital into our production function, that is Q is equal to a L raised to alpha. Instead of k, we will use this equation A, that is w by r beta by alpha L raised to whole raised to beta. The next, here there is 2L is there, L raised to alpha and L raised to beta. Then we can rearrange as A raised to, sorry, A into W by R beta by alpha whole raised to beta, then L raised to alpha plus beta Q. Then next we are solving this equation for L. Then L is equal to Q by A, that is multiplied by A, reaches here and it will become divided by A. The next W by R beta by alpha again becomes its reciprocal, that is R by W alpha by beta whole raised to beta. The next Here there is L raised to alpha plus beta. L raised to alpha plus beta. When reaches the other side, it will become whole raised to 1 divided by alpha plus beta. That is L is equal to Q by A whole raised to 1 by alpha plus beta into R by W into alpha by beta whole raised to beta divided by alpha plus beta. Then we obtain L is equal to Q by A, R by W, alpha by beta. Then next we have to substitute this L into the function A. That is, we can call it as B. Now we are going to substitute A, L into K. L into K. Okay, now we are going to substitute this L into K. That is, K is equal to W by R, beta by alpha. Instead of L, we will substitute Q by A whole raised to 1 by alpha plus beta into R alpha W beta whole raised to beta by alpha plus beta. Then rearrange it as Q by A whole raised to 1 by alpha plus beta. Then here W beta is on the numerator. Here also we can find a W beta on the denominator. By solving these two terms, that is W beta raised to 1 divided by W beta whole raised to beta by alpha plus beta, we take as LCM, that is 1 minus beta by alpha plus beta, and it will become alpha plus beta minus beta. Therefore W beta alpha by beta. Therefore it will become W beta whole raised to alpha by alpha plus beta. Similarly, here R alpha raised to beta by alpha plus beta is there, then divided by R alpha is also there, its power is 1. Then again we take it alpha plus beta as LCM and solve this powers. Then it will become beta minus alpha minus alpha minus beta. Beta minus beta cancel and it will remain as minus alpha by alpha plus beta. Therefore we can both these two terms, that W beta and R alpha, can be together written as W beta by R alpha with a common power alpha by alpha plus beta. Therefore we obtain K. Here we can rewrite, let us denote this equation as C. Then we have labor, we have capital, and now we substitute this labor and capital into our cost equation. That is cost is equal to WL plus RK. That is C is equal to W into L. L is equal to Q by A whole raised to 1 by alpha plus beta into R alpha by W beta whole raised to beta by alpha plus beta plus R into K. Here K is equal to Q by A whole raised to 1 by alpha plus beta into W beta by R alpha whole raised to alpha by alpha plus beta. Then let us rearrange this equation. That is C is equal to Q by A is common. Therefore we can take a Q by A outside as Q by A raised to 1 by alpha plus beta. Then here there is W is there, then again here W is there, Then we can again solve the w raised to 1 and w raised to beta alpha plus beta. Then what is remaining there? That is alpha plus beta minus beta. Then we will get w has a power, that is alpha by alpha plus beta. That is by solving w raised to 1 and 1 by w raised to b by alpha plus beta. Then what is remaining there in r raised to beta by alpha plus beta? Then alpha by beta whole raised to beta by alpha plus beta. Plus similarly when we solve r and r, then r raised to 1 and divide by r, it will become r raised to beta by alpha plus beta. Then w raised to alpha by alpha plus beta, then beta by alpha whole raised to alpha by alpha plus beta. Then let us rearrange this cost equation by representing the coefficient first and variable second. That is 1 by a whole raised to 1 by alpha plus beta plus into alpha by beta plus alpha beta whole raised to beta by alpha plus beta, beta by alpha whole raised to alpha by alpha plus beta into q raised to 1 by alpha plus beta, then r raised to beta by alpha plus beta, then w raised to alpha by alpha plus beta. That is again C is equal to a into 1 by a into alpha plus beta raised to beta plus beta by alpha raised to alpha one by alpha plus beta into q raised to 1 by alpha plus beta, r raised to beta by alpha plus beta, w raised to alpha by alpha plus beta. That is, we can write cost is a function of output, wage rate and rate of interest.